Good day, everyone, and welcome to today's DevOps.com webinar. We're excited to have you here. Our topic today is why you should not be using an RDBMS DBS for timestamp data. My name is Mitch Ashley, and I'll serve as your host and moderator for today's webinar. A bit of housekeeping: we are recording the webinar, and we will be sharing the contents of it, both via DevOps.com, and also our participants will receive an email with links to both the slides and the recording. Our speaker today, of course, loves questions, and we'd love to have you ask them. So please add them to the questions tab on the GoToWebinar software. So let's get moving forward. We'll jump right on our topic here. Why you should not be using an RDBS for timestamp data. Our speaker today is Thome Crowe, Community Manager at InfluxData. So let's get started. Tom, take it away.
All right. Well, thanks for having me. We're going to go ahead and jump right in. And what we're going to do is we're going to look at what time series data or timestamp data is, why you would be using that time series data, what some use cases are. We're going to look at the different ways that people store and query time series databases. And then we are going to look at the what we offer here at InfluxData. So let's jump right in. What is time series data? Easy enough. Time series data is any data that you're collecting that has a timestamp on it. So this is anything that you would be plotting on a graph. One of your axes will always be time. So if you're getting anything, for example, if you're looking at the weather, if you want to look at the temperature at a certain time, that's going to be time series data. This is a good example of some time series data. What we're looking at here is the usage of the hashtag royal baby back when Prince William and Princess Kate were expecting. We see along the x-axis, we're looking at the time of day, the day and time of day, and on the y-axis, we're looking at the tweets per hour. And there we see a big spike. We can get a clear indication here of when the royal baby was announced. This is a look at your more relational database model here. We've got information about this person here in the center. We can tell that she listens to Spotify. You know, we can see who her friends are. She likes Facebook, she cooks, she watches Netflix. We're getting a lot of information about her, but absolutely none of this is related to time. This is a weather station data logger, like I had mentioned a moment ago, collecting some weather data, including temperature. You look at all of these charts here, all these graphs that we have here, everything that we're measuring, the temperature, the barometric reading, the dew point, everything is being measured in relation to time. So we're seeing how that measurement is changing over a given time on these graphs. This scatter plot is not time series data. What we're looking at here is we're looking at different social groups within a school, how well they perform athletically, and then what their grades look like. You can see that we have all those different groups. We can tell what their grades are, how active they are in athletics. We're getting a lot of information about these different groups and how people identify in these groups and perform, but none of it is related to time. This is one of the more common uses we see for time series data. This is looking at disk op writes. We're looking at what percentage of the disk is being used. We're looking at a short-term load on the disk. This is what as you're monitoring your system, you're seeing how things are performing and what's happening over time. Again, we're looking at tweets again here, and we're looking at the what percentage of tweets are coming from what countries. We've got the countries listed along the x-axis. We can see what percentage of tweets those are. We don't have any time series data here. Now, if we were to look at what percentage of tweets are coming out of which countries at specific times and how that changes, we could turn this into some time series data that we could track. But as it is right now, this is not time series data. And we've got this graph here, which shows the growth and popularity of Ed Sheeran's song Sing as tracked by Shazam. It's not a traditional XY graph, but we are tracking the growth and popularity over time. So we're seeing these different time intervals and the spreading of this song. So we're seeing how the song is being, the song popularity is growing over time, making it a time series data, but again, not in a traditional time series data graph that we typically see. Another good use of time series data is monitoring those core CPU loads. Look right along that x-axis, and we've got all of we're seeing how these data points are changing over time. We're following the database load, the network switch, and the storage array, and we're seeing how those are all changing over time over the last 5 hours. This is a little almost misleading. We're looking at how long students spend studying versus what grades they get. Yes, time is on the x-axis, but this is not a time stamp. This is not a specific point in time that we're monitoring. We're looking at, like, if they spend 2 hours or 4 hours. Now, if we were to take this data and we were to look at what time of day students study and how that affects their grades, we'd be looking at time series data. So time series data is coming in 2 different types of measurements that we have. We have metrics, which are regular time series data points, and then we have events, which are going to be those irregular time series points. Regular metrics are things that are gathered at specific time intervals. So if we're looking at that temperature and seeing what the temperature is every 30 seconds, or if we're looking at how stocks change over the course of a minute, that's going to be regular time series data or metrics. Now, if we're triggering an event every time something happens, that's going to be that irregular time series data. For example, if we're plotting every time a stock changes, that's not going to happen, at a set time. There are a lot of factors that go into that. So we're going to plot all of that, and that's going to be our irregular time intervals or events. Again, all of our metrics are regular time series data points, and that's the measurements that are gathered at regular time intervals. We know they're coming in and we're expecting them. Events are our irregular time series data points, and those are coming in at irregular time intervals triggered by some event that's happening. What we can do is we can take those events and turn them into metrics. For example, as I said, if we're tracking all the changes to Apple stock, for example, that's going to happen over irregular time series data points. But if we take and we average that out over every 10 minutes and look at how that changes, suddenly we took that irregular data or those events and turned them into regular data or metrics. Same thing for the average response time for requests in an application over 1-minute intervals. Those requests and the response time are going to vary based on the needs and when those requests are coming in. But if we average them out over the course of a minute, we've turned those events into metrics.
Tom, if I could jump in, this is Mitch, with a question. Would you differentiate, or how would you differentiate timestamp time series data versus just log data, which also have a timestamp? Is that a subset of what you're talking about, or 2 different things?
It is. If your log data has a timestamp on it, that is a type of time series data. That is a great question. Yes, so if you're pulling in logs and you've got timestamps on those, that is going to be time series data as well.
Great, thanks.
So now that we've got a little idea of what time series data is, let's look at what a time series database is. A time series database is a database that is built specifically for time series data, right? So it's going to be pulling in all of that timestamp data. It's going to be generating the data that's coming in metrics and events over different time periods. A big characteristic of a time series database is that it's going to be pulling in huge volumes of data. I mean, if you look at, for example, I think it was Intel said that every autonomous car that's sending data is sending in 4,000 gigabytes of data every day for those self-driving autonomous cars. That's a lot of data. So we know that these databases have to be built for those high ingestion rates and the large volume. And the data that's coming in is going to be brought in real time. And a lot of times what we're using it for is going to be time sensitive. Time series databases are optimized for collecting, storing, retrieving, and processing time series data. Now, if we compare this to, let's say, a document database, where those are optimized for storing like the JSON or BSON documents. And when you're doing that, those documents you query against the documents. So let's say you're bringing in time series data. you're going to put that time series data in a document and then query against that. It's just not what it's built for. Search databases are optimized for full text searches. Traditional databases are tabular and are typically storing data in rows and columns, which is not necessarily the most ideal way to store your time series data. In time series world, your data shape is always changing. So when you're querying and you're querying against an individual series, in traditional databases like a relational database, you're more concerned about those columns. And that, like I said, that tabular storage just isn't optimized for time series data. So what are some people using for time series database to store their time series data? We see people using stuff like Cassandra. Cassandra is that column distributed database. You can use Cassandra for storing time series data, but you're going to end up implementing a lot of things that come standard out of the box with the time series database. It's more work for the use case. And the question you really have to ask yourself is how much overhead and extra work do you really want to put in with custom tooling when you can just use a time series database out of the box that works? Same thing with MongoDB. You know, it's not particularly suited for storing a large single numeric or string value and following that and how that string changes over time. Elasticsearch, it's great for pulling in metrics, but when you go to, it can be great.
Hey there, Tom, are you with us? Hope we didn't lose you here. Just checking in. Tom, are you still there? The joys of modern technology. Hope we haven't lost Tom completely. If you're there, Tom. Oh, okay, there you're back. It looks like we lost you there for a minute. Couldn't hear you. So the last 30 seconds, I think we lost. If you want to step back just a little bit in your time series conversation.
Okay, Elasticsearch can pull in those metrics. It's not really designed for that. So it's going to take a lot of work to get the value that you need out of those metrics that you're storing to get the data that you need. And it's not suited for data metrics over a specific time period. You can use it, but it's not very efficient. And then we look at some other time series databases out there. For example, KX Systems. KX Systems is popular in the financial world. It's an in-memory disk-backed database, but there are use cases where you'll need more than one machine. And when you need more than one machine, more memory than you can put on one machine, you're kind of in a difficult situation that you have to work your way out of. Graphite is a legacy time series database. It's not a generic use case for all time series data. It's built specifically for metrics and monitoring. Some of the issues that you run into there, though, especially in DevOps, is the automatic roll-up of data. You're going to lose that individual and irregular data that you may want to store. You've got OpenTSDB, which is not actually a database in and of itself. It's a layer that you put on top of HBase. So in order to use OpenTSDB, not only do you have to set up the open source TSDB instance, you have to put that on top of HBase and manage that HBase to use it. Then we have RDBMS tool, which is used for logging and graphing. It's a round-robin database. So one of the issues you run into really quickly there is that the database size is defined at creation, and it's limited to that. So as your data grows, you're not going to be able to use it as natively. You're going to have to reconfigure. It's not an easy process to update. And then we have like Prometheus, which is big in DevOps. Prometheus is difficult to manage with high availability, and it's unfeasible really to scale out horizontally. It's not suitable for a use case where you're going to want to scale out. When you're looking at these two options and you're thinking, how am I going to store my time series data? You really do want to look at a time series database, namely because of that scalability. Like we mentioned, traditional databases are not designed to handle 4,000 gigs of data coming in every day. And the usability, time series databases like these and InfluxDB they have built-in data retention policies that you can work with. They give you continuous queries. There's flexible time aggregations, and you can downsample your data. As we look over the last 2 years, you can see time series databases have been really growing. They've been something of interest. The growth of time series data is outperforming even graph databases, which are really popular right now, and they're outperforming search. You can see there's been a little dip over the years in the use of relational databases. Within that time series database world, InfluxDB is the largest and most popular database used. According to DB Engines, you can go there and look at all of this data from DB Engines. So now we have a good understanding of what time series data is. We've looked at what different kind of options you have for storing that time series data, and we see really the benefit to a time series database. Before we go any further, let's look at some use cases for time series. What use cases do you have that would work well for time series data? And we see really 3 big use cases. One is IoT or IIoT, which is where you're going to see, factories, oil and gas, agriculture, smart roads, and infrastructure for that industrial IoT. For example, if you're looking at a wind turbine, there are sensors on every part of that wind turbine to ensure that it's working correctly, or a drill in the oil and gas world. Because if that drill goes down, you're losing a lot of money. Everybody's still working. You're not able to move forward towards production. So every bit of that data from that drill is being pulled in. And then consumables. If you're like me, you've got your Apple Watch on right now. It'll tell you how many steps you've had. You can go look at that data, how many steps you've taken throughout the day and at what time period. That's all time series data. Same thing with the data your Nest or your at home thermostats are collecting. DevOps, big use case. DevOps, people use it for custom monitoring of your application, of your users, your events, the whole spectrum of everything that you're running and orchestrating. You can also use it for monitoring, like intrusion detection systems can be applied with data that's coming into time series database. Time series data is really big in DevOps. And then of course you have real-time analytics, which are those business, social, or development metrics in real time. So think of stuff like high frequency stock trading or tracking how a business is performing.
Tom, we had a question from Rudy in our audience. He asked, would IoT data be time or event data, or perhaps both?
It is going to be time series data. Those events that it's triggering are going to be your event data that's going to come in. So for example, we'll go back to that watch example. If it sees that you're not moving, it's not going to store any data. But when you're walking, it's going to grab and start putting those data points in that you've been walking for X amount of time and you've done X number of steps in that time period. Does that make sense?
I think it does. I think
Perfect.
maybe the events this person might be thinking about is sometimes in a device appearing or disappearing might start time series type of data being collected.
Yes, that would definitely, yes. So that would all come in as time series data and be stored as such.
Great, thank you.
You bet. So here at InfluxDB, we have an entire platform that's for bringing in all of your metrics and event workloads. You can see we pull in information from like IoT event sensors and events like we were just talking. You can get it from business metrics, your applications, custom logs and traces, your infrastructure, and all of your application metrics can come in to InfluxDB. And what the InfluxDB platform enables you to do is to instrument, observe, learn, and automate. So you're able to quickly ingest all of that data from multiple disparate data sources, and then have it stored, efficiently compressed, so that you can keep that data at scale. It gives you the ability to observe. You can do real-time queries. You can look at analysis of your data. You can visualize large sets of data on the fly. It provides time-based functions for change over time analysis and control. You can then once you have your data in, you've been able to observe it, you can then learn from it. You can facilitate machine learning and anomaly detection algorithms. You can provide streaming analytics for data in motion, and then you can take what you've learned and automate as well. You can provide automation and control functions. You can have it automatically evict and downsample data that you either don't need as granular of a view, or once the data is old and you don't need it anymore, you can evict it. At InfluxDB, we have two real offerings. We have our open source projects, and then we have our commercial offering. Within our commercial offering, we have two offerings available. We have InfluxDB Enterprise, which is for enterprise customers. It can be on-prem. You know, you've got your choices on how you deploy that. It does come with clustering, managed availability, high availability, and security features built in. And then we have our InfluxDB Cloud, which we just released Cloud 2.0 last week. It was a pretty exciting time here at Influx. And that is, think of it as a platform as a service. Everything is in the cloud. You can start bringing in your data, visualizing, querying, storing everything in the cloud. Most of our users are on our open source offering. We have over 250,000 instances of the open source core versus, you know, around 500 of our customers in the commercial offering. Within our open source projects or our open source core, we have 4 projects. We have Telegraph, InfluxDB, Chronograph, and Capacitor. Telegraph is our agent for collecting and reporting metrics and events. There are over 200 plugins that help you pull in data from various sources and bring it into InfluxDB, which is that database that's built specifically for time series data. You can use our libraries to write data, stuff like we've got libraries for Go, Python, JavaScript, etc. You can write data in that way, and you can instrument them and format them within InfluxDB. We have Capacitor, which is for real-time streaming data processing. So you can set thresholds and send alerts through monitoring services like PagerDuty, Ping, Slack, and then bring that data back into InfluxDB for store as well. And then Chronograph is really it's our user interface for the platform for querying and packed full of visualization tools, including pre-canned dashboards right out of the box. When you go with something like InfluxDB Cloud 2.0, all of this is just built in and works together. You don't have to think about each individual component. It's all just built into the InfluxDB Cloud platform. But let's take a little bit closer look at how all of this works together. Your data will come in through Telegraph. Like I said, you've got over 200 plugins, and that's going to pull stuff from your Kubernetes stats. That can be your from the nodes themselves, from individual pods. You're going to pull in data from your databases and apps, from networking, it can scrape Prometheus endpoints, and you can pull in logs and traces. Let's say that you have some legacy applications or some legacy software that you want to get data from as well. You can build your own plugin if it doesn't exist and make that happen. So really, Telegraph enables you to pull data from literally anywhere you can imagine. All that data comes into InfluxDB and Capacitor. When it's in Capacitor, it's great for facilitating functions, machine learning, anomaly detection, and alerting. It can push that data. If there's something off, it can push that data into an alerting framework and let you know. When it goes into InfluxData, it is compressed and stored so that you can begin querying immediately. You have access to all of that data. And then all of the data gets passed in through Chronograph, where it can be visualized or queried. Chronograph has some built-in pre-canned dashboards for things like Kubernetes, for various, for network, for your monitoring your system that are just ready to go. So you can start ingesting data and getting real information out of it right away. So now that we've looked at the use cases, why you'd want to use time series data, and we understand what time series data is, and we know that we have several options for how we would store time series data, why would you choose InfluxDB? InfluxDB, when it was designed by our co-founder and CTO, Paul Dix, he wanted it to be simple. He wanted InfluxDB to be something you could get started with within minutes. It was built to have a familiar query syntax. What we do looks a lot like MySQL. Everything you need comes pre-built in. There are no external dependencies that you need to worry about or monitor. It allows for regular and irregular time series data. So no matter if what you're pulling in or what combination of data you're pulling in, it can all come in. It's designed to be horizontally scalable. And what I like most is it's a member of that cohesive time series platform. We hear from our community members all the time that the ability to switch things in and out and give them freedom from architectural lock-in or vendor lock-in and to remain agnostic in what they're doing is really important to them. It's a step in towards democratizing tech, which is a pretty great thing to be a part of. Do we have any questions so far?
Yeah, thanks for pausing. There's a couple of questions. One is, in this kind of an environment where you have time series data, are you kind of faced with a typical rigid database schema that you're working with highly structured data, or are there provisions for dealing with many kinds of kind of data that's coming along with time-stamped or time series data? How do you look at that problem?
There are provisions there, and what we'll do is we get a little further in, we're going to look at the InfluxDB data model, what the model looks like, and then we'll also look at how you bring data in. You know, there's a lot to take into consideration, but we've built for things to help you bring in your data, be able to query it quickly, and avoid cardinality issues, which we'll show here in just a little bit.
Okay, great.
Yeah.
I think another thing kind of related to that is the ingestion of data coming from sensors or all the endpoints or devices that are collecting data. Is this a store and forward mechanism, or what kind of provisions do you have to be able to collect large quantities or large number of devices that are all sending data for you to be ingested into InfluxDB?
Absolutely, as it's coming into what we call line protocol, where we have different fields where we can put in those sensors from different fields, collect all the data, and then we can query against whatever we're looking for. So let's say we're looking at all of our sensor data at one power plant, for example, or we can query against everything at that the field set that's tied to that particular power plant. Let's say more importantly, we want to look at one particular machine at that power plant. We can query against the field that's denoting that particular machine. Does that make sense?
Yeah, it does. It does. Sort of related to this accessing data, Sujit asks a question about, does InfluxDB work with native data from a data lake?
Sure. If you can use once you set in a plugin or have a way to bring in that data from the data lake, you can query against it. I would imagine your data lake is going to be a whole lot of data, and depending, I'd want to understand a little bit more about what you're thinking, what your use case is there. But yeah.
Okay, great. Maybe Sujit can add a little bit of color to that, and we can pursue that further. He also asks, does Influx have a Kafka, Apache's Kafka for streaming, a connector to Kafka?
We do.
Not surprised to hear you say that, Tom.
You can definitely, in one of the examples we're going to see here in a little bit, you'll see how Kafka plays into one of our customers' overall architecture that they're using with InfluxDB.
Okay, I think this will be a low-hanging fruit question for you too. Does Influx have JDBC, ODBC drivers?
Yes.
For Java applications? Yep, I would guess so. That's probably one of the early on to have.
I'm pretty sure. Yes, I'm not a Java guy myself, but I'm pretty sure we do.
Okay, we can validate that too. Okay, good, good. Well, I think we've knocked out a number of questions there. So I'm interested to jump into the data model.
All
I'd love to hear more about that.
So we're going to look at real quick, get an idea of how the data is structured and brought into InfluxDB. We're going to look at a typical time series graph. Here we have a graph that is monitoring what three different stocks are doing over time. We see we have stock A, stock AA, and stock AAPL, and you can see how those are changing over time. In the InfluxDB model, we're going to call that stock price up there, the label that we're measuring, we're going to call that our measurement. The metadata that we're using in this legend, those three stock prices, we're going to call tags. and these tags are all indexed, so you can query against the tags. We could have more than one tag that we're tracking and indexing, and that when we do that, that's called a tag set. So for example, here we're seeing that the ticker, the stock ticker A is in the New York Stock Exchange or the NASDAQ, AA is in the New York Stock Exchange, and AAPL is in the NASDAQ as well. What we're measuring against the Y value here, we're measuring price, and we call this a field. And the fields that are stored can be brought in as floats, ints, strings, or bools. You're not limited there. You've got a lot of options. And then of course, and then we could have field sets. We could have multiple fields that we're storing. In this case, we're only doing one, but if we put multiple fields together, that's going to be a field set. And then of course, on the x-axis, we have the timestamp, and then we call it creatively the timestamp. So how do we represent points textually within InfluxDB? So points look like this, right? We've got our measurement, comma, our field set. We have ticker A, comma, market, NASDAQ. And then we put a space there to separate and differentiate from our fields. And the first field we're going against here is price equals $177.03. Another space, and we're pulling in that timestamp. If you look, all three of these rows are structured the exact same, and that's called line protocol. In line protocol, we bring in all data and store it as measurement, comma, tag set, space, field set, space, timestamp. So again, we've got stock price, comma, ticker equals A, comma, market, NASDAQ, space, because we're going from that tag set to the field. We're putting in the price, space, and then we've got that timestamp. And this is how data is ingested into InfluxDB. Points are written using line protocol, which follows this format. And here we can see a field set. So in this instance here, we're measuring the CPU load, and we're looking at a server, and we're looking at where that server is located. It's in US West. And from that server, we want to know what the temperature is and what the volts are. And we're measuring both of those, separating them with a comma, that field set with a comma, and then we've got our timestamp. When we're looking at the series as a whole, we're looking at the measurement and all the tag sets. So we're looking at that, that's the series as a whole. When we look at a single point, when we look at a measurement, a tag stamp, and a timestamp, that's the single point we're looking at. And all of the single points make up the time series as a whole.
Question for you, Tom, about the tag set. Are those predefined? Are there one set of tag sets to kind of draw from, or that you build up over time, or is that just each data source can have its own set of tag sets, and sometimes they intersect with others and sometimes they don't? How does that work when you're dealing with large quantities and different kinds of data?
So your tag sets, you define your tag sets, and they can overlap from multiple data, if you're pulling in data from different places. So for example, if you're pulling in all of your data from a specific data center, and you're pulling in everything that's happening off of different servers, and you're wanting to one of the tag sets is that server location, and you're also pulling in, say, for example, the temperature of the server room. Well, that's a completely different data source that you're pulling from, but you could have that with the same tag set, and then you can using joins, you can query against that and see what the performance is on those machines, and how that correlates to temperature, for example. So yeah, you've got a lot of flexibility there with tag sets.
I would imagine you mentioned correlating. I was just thinking about that too. Thinking about those tag sets probably is going to help you a lot with how you correlate data across different sources or times.
Absolutely. That's a great point, Mitchell.
Well, it was yours, so it was easy to bring up.
So let's look at a few more examples real quick of what that line protocol looks like. In this first case, we're measuring the CPU on a host, which is on server 1, and we're getting that value of 100, and that's the timestamp. We know exactly when it happened. The next one, our measurement is temperature, and we've got our tag set, which is the zip code and the country, so we know that this is in California in the US. We've got a space there to differentiate the field set, and the temperature we see is 75 and the humidity is 10, and that at that specific time point. And then, as we said, you can pull in your fields in various formats. So on the next one, we're measuring that response time, and we're using a method of get per millisecond. And the field there, that value is 12i, and then we've got our timestamp as well. So let's look at a couple of use cases right now with how customers are using InfluxDB. The first one we have here is a company called Bbox, and what they do is they provide power to people in rural Africa who don't live near a grid. And what they realized was that if you don't live near a grid, it's extremely expensive to get power to your house. You have to buy your own solar panels, you have to buy and maintain all of your own batteries. And what they decided to do was they wanted to create a model like we have, where you can just plug in an appliance and go. So they are they're allowing people to share the cost of the solar panel and the batteries in order to get power to their homes. And since they are in rural Africa, they've got a very unique problem, and that's how do they get that data from rural Africa into AWS where they're storing it, and how can they make that work? What they're doing is they are piping in all of their data over a GSM network, and all that raw data is going into InfluxDB, and they are importing it to InfluxDB. They're not using Telegraph or Capacitor. They've got their own home-built solution, and they process that data back to their own tech where they're able to query that data, store it, and everything. Their data helps them a lot. So for example, they're able to see a lot of things with the data that they couldn't see before. For example, they can look at their data and they can tell when a football game is on based on the usage spikes. Or they can look at how the solar panels are performing and tell that there was a solar eclipse. There were some things that they didn't really anticipate at first. They were having a problem with customers complaining that the batteries weren't holding a charge. And they looked at all the data and they saw, well, the battery is performing as it's supposed to, the solar panel is working, everything's working, but what they hadn't anticipated that they could see really quickly from the data is that people were using their lights 24/7. They had assumed when people were awake, they would turn on their lights. When people were asleep, they would turn them off. And that's not what happened. So they were able to go in and replace some of their equipment so that people were able to use their lights overnight for things like security. If you're in the middle of nowhere with no near neighbors, those lights outside are a little bit of added security for you. What they learned really quickly is that those first data points that they were connecting were not the only data points they were going to want. So they're pulling in all of these data and sensors from their equipment to look at usage, but they're also pulling in weather data, for example, and they're able to do, again, like we were talking just a second ago, Mitchell, they're able to correlate that into performance.
It's a really interesting example too. Yeah, you can think about how that might tie into other IoT devices around the home that are more active at night versus the day.
Absolutely. Here we're looking at their line protocol that they're using. This is how they have their data coming in, and their measurement there, they're pulling in telemetry, and they've got 3 fields they're measuring against. They're measuring voltage, they're measuring current, and they're measuring the temperature. And that tag set they have there, we were talking about this, how we could do different tag sets, Mitchell, to find correlation. They've got the product ID. They've given these random, or each of these are assigned a product ID. And then they've got the battery type. So they're using lead acid or lithium potassium batteries. And they can query here to look at all of the lead acid batteries and see what their performance looks like and how they degrade over time, and see if they're the best option and compare them to how other battery types are performing, as an example.
If you could solve the battery problem, you'll have a lot of popularity in the community.
I think that's the quickest way to retirement, is to fix that battery problem, right?
Exactly.
One of our largest customers that we have is Wayfair. And if you're familiar with Wayfair, they're a website that sells home goods, furniture, things like that. And Wayfair is tracking the entire user journey during their, and they're tracking that workflow, and it's extremely important that they're getting all that data. They need to ensure that their users aren't getting any sort of weird experiences, that the backend data is available in a timely manner, and that they're able to use that data to see how their business is performing. So when they do their Cyber 5 holiday weekend, which is coming up, it's like the Black Friday, Cyber Monday sales, they're pulling in over 20 million real user measurements, which is just an insane amount of data daily. It's going across 8 stores. They've got hundreds of page types, and they're tracking thousands of different device types. And they need to ensure that their users are having a solid, good experience. That way they're able to make their purchases during this busy retail time. They're also pulling all their data center metrics. They have hundreds of apps that are sending metrics from multiple data centers. What they've been doing is they are also working with, during this time period, they're deploying hundreds of code changes to the app. Each of those has the potential of impacting performance for better or worse, and has bearing on other parts of the app. So they're able to use the time series data and to look at the performance and make sure that everything's working as it should. They've worked with us here at InfluxDB to ensure that they're implementing InfluxDB in a scalable, robust way, and that it's in line with where we're headed for our enterprise development. And they've helped us a lot understand what the InfluxDB enterprise feature requests and needs are from our customers. Their architecture looks quite a bit different from what we saw previously with Bbox. Here they've got there's a multi-layer pipeline with telegraphs, so they're receiving all the raw InfluxDB line protocol from applications. They're getting that from UDP, and they're forwarding it on to that Kafka instance, as we had a question about earlier. You can see how Kafka is used here. They consume the metrics from the Kafka buffer, and they write it to InfluxDB. This example here, they've got 3 data centers. They're now up to, I believe, 6. So they connect these multiple data centers by mirroring Kafka topics to shuttle the metrics. And they're able to inject the various processing hooks into the data stream as the business needs to evolve. It's easy for them to write the same data to multiple instances. What this really gave them, they were excited about, was the multi-day tolerance against a severe network issue. What they were using before was Graphite, and they hit some issues with Graphite. Graphite didn't provide them with any clustering options. The storage infrastructure was difficult to manage. It didn't just work out of the box with a pipeline solution that they needed. They quickly maxed out its performance potential, and there were no shard relocation, backup, or restore. So if something happened to their Graphite instance, they had some big problems. They moved to InfluxDB. One of the things they liked was the fact that we're continually pushing forward performance improvements, and that we do support true clustering. They particularly like the fact that everything was written in Go, and that's a language that they're familiar with. They're able to use it in their multi-core environments. They also like our community and the ecosystem of related tools for building enterprise-wide adoptions. When I say they like our community, I'll give an example here. One of their engineers who heads up their Influx efforts also runs the time series meetup, which is our meetup in Boston, and is really involved in the community and spreading the word about InfluxDB there. And they like the fact that we have a growing base from customers from diverse companies, so they're able to learn how other companies are using InfluxDB and learn about other implementations that they may not have thought about that they can take and apply to their own business. So next we're going to look at Playtech, which is a pretty unique use case. They are a gaming developer platform. So for example, you can build a poker game on their platform and then deploy and run it and use them as your backend. They have over 50 multi-branded sites. They're all over the world, and they have several products and channels that they run. They have to handle financial transactions, and that, which, as we all know, are heavily regulated, but those regulations vary from market to market. So they have to be compliant with everything that's going on with the Canadian banking regulations, with banking regulations in the United States and the EU, et cetera. And they have a lot of different variations on their backend. InfluxDB is a major component to providing observability for them. They do their low-level monitoring, so the stuff that we think of like the CPU, the disk usage, the memory usage, that sort of stuff. But they also do their high-level monitoring and all their KPIs. They're looking at the user sessions, the payments, transaction amounts, logins, and they also use us for their organizational level monitoring. So they're able to map out all their products, who's responsible for what brands and sites are tied to the internal chart, and they're able to see who wrote code, all using InfluxDB. What their architecture, again, we have something that looks completely different from anything we've seen yet. All of their event data is piped into InfluxDB using their own definitions to define what different things mean down to the microservices level. Everything goes through the messaging queue and the systems and works asynchronously. They use Alerta for incident management, which has been great for them. They use it to deduplicate a lot of issues that were coming in and identify where those were coming from. They were using a legacy product called HP Service Health Analyzer. And for them, they said that the SHA was a black box. It was impossible to change the settings or tune anything once it was up and running. The SHA was yielding huge volumes, huge amount of false negatives and false positives, which were creating problems for them. And when you can think about running a platform for developers to build apps, having granularity of only 15 minutes is a huge issue. And then it just didn't work as expected. It was trying to be one universal instrument and it just couldn't pull it off. So they went to InfluxDB for all, they use all their time series database for any metrics come into InfluxDB. They are, again, big supporters and contributors of the community. One of their developers is launching our time series meetup in Estonia and came to speak at InfluxDB or Influx Days Europe. Then we have they like the fact that it's fast and reliable, and they really like our support. We've got one more example here just to show you an industrial IoT look, a look at an industrial IoT use case. We're looking at ANS Energy, which is a Belgian biomass plant. And what they do is they take non-recyclable wood, burn it, and turn it into electricity. They had an antiquated historian that just wasn't cutting it for them. So they partnered with a company that uses InfluxDB to get a new historian. The company's called Factory. And they had the typical industrial IoT challenge. If something goes down, if some part of this system breaks down, that's going to cost them money. And it was really hard to identify where the problems were coming in because some of the stuff was written down on paper, some of it was put into an Excel spreadsheet, where I like to think, where I think of things that go in Excel spreadsheets, it typically disappears into the world, into a black world where it's never looked at again. And then we have their existing historian was underutilized. The data wasn't being used to extract meaning, and they only had 2 weeks worth of data. So Factory came in, they used an OPC UA connector to start pulling in all of this data from various sensors. They had to pull in data from, like Siemens, Rockwell Automation, Schneider Electric, because they're already invested in all of this equipment, and it's very expensive. They need to make sure that it's all working correctly. Like I said, using that OPC UA collector, that data everything that's timestamped comes into InfluxDB. Everything else is sorted into Postgres, and then all of their data is then put from InfluxDB into a Grafana dashboard. And what they've done is really neat. They have custom Grafana dashboards for everybody in the plant. So if my job is to work on this one machine, I can pull up and I have a Grafana dashboard that shows me how my machine is working. If I'm a manager and I'm managing 10 machines here, and 10 people and 10 machines, I can pull up my Grafana dashboard and see how each of those are performing. If I'm the plant manager, I can pull up and look at how the entire plant is performing. Using the data and the data coming in InfluxDB and visualized into Grafana, they had 2 guys on their staff who were able to find a leak in a tank early, and they say it saved them an estimated $500,000. So it was a pretty big deal for them. Their existing historian they only had that 2-week retention period. They didn't have access to long-term data. There were too many disparate databases and collection of data, some on paper, some on Excel. They were pretty concerned that it was built on legacy software. It was built on Windows 2000, and as you know, Windows 2000 stopped all support of Windows, or Windows stopped all support of Windows 2000. Everything was just like it was thrown into a closet and disappeared, and it wasn't easy to expand on or learn from that data. So when Factory built their new data historian with InfluxDB, they were able to look at the real-time and historical insights for everyone, from that machine operator all the way to the plant manager. It's able to handle those high write loads. A big plus for them was that it was platform independent. It's got that agnostic approach. Most historians are built on Windows systems. They can build this on whatever they want. And then they have the option for data retention policies. They can keep data in its original resolution as long as they need, or they can downsample and evict data however suits them. So let's do a real quick example here. We're going to go through and show you how easy it is to write data into InfluxDB and start, so you can start using it. So once you, this is for downloading InfluxDB. Once you download InfluxDB, you can create a database. And here we just type create database, mydb. And we're going to go ahead and type in show database. And we will see these are all of our databases that we have. And there's that mydb that we just created. We can type use mydb. And at that point, we are now using the database. We can start bringing in data. We take all of this sensor data, all of this data in line protocol that we have, paste it in there. We see that it's come in. By just running the code show series or show measurements, we can see all of the data from the CPU. We can see all that CPU data visualized as it's come in, and we know it's working. There's also now, like I said, we launched our InfluxDB Cloud 2.0, and there is a forever free tier there that you can get started with. And if you log in there, you can set up a data connector and using Telegraph and pull, for example, your system performance from your computer or your laptop, and you can visualize that. I did a workshop in Minneapolis a couple weeks ago with one of the architects who built Cloud 2.0, and when I was making the presentation for it and building out the workshop, I wanted to see how long it would take me to go from nothing to collecting system data that I can visualize. And so I set a timer. I signed up for InfluxDB Cloud 2.0. I already had Telegraph installed on my machine, but then I started pulling data into Telegraph and went to visualize it, and it was all under 3 minutes. It's really easy. Like I said, there's a forever free tier you can check out and get started and start learning what you can do with your time series data.
What about jumping in here? Just what about facilities to be able to do like a proof of concept development? Is there some kind of a online sandbox people might use to jump right in and start working with a tool?
Yeah, I would say jump right in with Cloud 2.0 and give it a shot. Like I said, there's a free tier there, so you can start pulling in data and visualizing, build out a proof of concept, see just how powerful it really is.
And can you do that all in the cloud when you say Cloud 2.0?
You can.
Is it all? Doesn't have to do anything on your servers or your development environment?
You can do anything you want. I think it's that platform as a service, so you can pull in that data. It's all stored there. You can query in the app. You can by either writing a script query, or you can do a query builder. You can visualize everything in dashboards. It's all ready, good to go out of the box.
Great. Talk a little bit about then too, when you move past proof of concept, you're doing development, put things into production. How does that cloud environment tie into your production environment, if that's where your data is being ingested from a production system or systems?
Once you're ready to go, you can input your credit card information. All of our billing is very straightforward, and there's no lapse. You can go straight from that proof of concept and get up and running into full production, ready to go in no time. And depending on what your needs are, there are some developers out there who are going to be using the Cloud 2.0 free tier and posterity. It's going to work for them indefinitely. So I like it. It's not having to manage, keeping my database, not having to manage, where my database is stored, keeping it up, all of that stuff. It's just all ready to go in the cloud, managed by people who are keeping an eye on it and know that everything is working as it should be.
One less thing to maintain, to update, to worry about. Exactly. I get it. And all about that. So the data that's going into the cloud service, is that real-time ingested? I say real-time relatively, or is that something through kind of an upload process? Can you tie it directly into a real-time ingestion, or how does that happen?
You sure can. You can set up a Telegraph instance that'll pull it all in real time. So there's no delay. You can query against your real-time data as well. And it's got it, yeah, it's got everything built in. It's got, we've got alerting already for, you can set up alerts for PagerDuty without, with a paid account, with a full InfluxDB Cloud 2.0 account. You can start setting up your notifications and alerts straight from the app.
Okay, good. And can that also be from other cloud environments like an Azure or AWS, Google platform? Can the data be the source from those environments?
Yeah, you can ingest all of that using Telegraph. You can get data from just about anywhere you can possibly imagine.
Okay, that's your universal translator adapter, sounds like.
It is. It's that agent that we have for collecting metrics and events. And with like I said, with over 200 plugins, you're going to find almost everything you need. You can pull with one of the plugins. And if you can't, we've got a ton of tutorials on how to build a plugin. If you've got some legacy system or some legacy software you need data from, you can write a plugin to pull that as well. Mm-hmm. We're working, we're doing right now all of our community data we're pulling into InfluxDB Cloud 2.0, and so we're looking at we're building a couple of plugins right now that help us visualize the strength of our community, and it's really a pretty powerful tool, that the ability to build your own plugins.
Mm-hmm. Well, speaking of that, I believe you said that this is written in Go. Is that the case? And is that sort of the ideal environment to work with, or no, really you can use whatever you want?
You can use whatever you want. It's just that our what we've built, we built everything on Go, but we've got plugins and integration for just about every language you can possibly imagine. Yeah, we've got stuff for C++, we've got stuff for JavaScript, we've got stuff for Ruby. Yeah.
Very nice. Another question is, and this is kind of taking your perspective, you're in a very unique and kind of cool role where you get to work with a lot of different organizations as the community manager. There's sort of solving problems in some of the use cases that you gave, which were really interesting. And then there's also what could you use with this information now that you have access to it and you have the ability to do analysis and pull kind of intelligence from it. What do you see as some of the kind of higher level, moving from high school to college to graduate school level of capabilities that you see people doing now that they have access to this kind of time series data?
We're seeing a lot of really cool stuff. So we've got one company in Europe that we're speaking at IoT World with, and they are helping orchestrate smart cities with this data. And one of the things they're doing is they're pulling in real-time traffic data from all over the place to help emergency responders get from point A to their destination, get from where they are to where they need to be in the quickest and easiest time using real-time time series data. And that's one of the coolest use cases I found. I mean, that's literally, in a matter of life and death, we've got a product that people are using for those precious seconds that can be the determining factor. And then, we've got, we have also all sorts of other stuff. One of the fun use cases we saw was a guy who really likes to barbecue at home, and so he's got sensors in his barbecue grill, and he's pulling those into InfluxDB, and he's looking at the outcome of his, what he's barbecuing, and looking at the temperature and what happened over the course of that, smoking or I think it was smoking or barbecue. I don't know if it was true barbecue or smoking, and being from Texas, that's a big distinction. But he was looking at, what happened inside, while the meat was cooking, and correlating that to what the final outcome was. We've also got people who are monitoring their home brew beer setups to make sure that, everything's staying where it should. And if it doesn't, what effect does that actually have on the final product?
Well, it always comes down to the Maslow's pyramid of needs, right? Barbecue and home brew. So, right. Well, it looks like we've kind of hit at the top of our hour. Any last words you'd like to offer, Tom, before we wrap up?
I would just really recommend jumping in and giving that InfluxDB Cloud a try. I think you're posting the link to that in the chat, right? And then we have a wonderful community. Our community is absolutely amazing. And we have a Slack channel where you can engage with people from Influx and from our community to help you get started, or if you run into any roadblocks or have any questions. Our Slack workspace is a great place to get help moving forward and jumping right into InfluxDB.
Fantastic. And we posted links to both, and we'll include that in the webinar description when that's published. Well, thank you, Tom. Just an amazing webinar. It's great to hear about not only the technology, but what people are doing with it. So I'd like to thank you, Thome Crowe, Community Manager at InfluxData. And of course, we'd like to thank our sponsor, InfluxData, and also our audience and the wonderful questions and just your time that you spent with us today. It's been my pleasure hosting today's webinar for you. Have a great day and be careful out there.
Thank you so much. Bye-bye.